Thank you, sir. First of all, I would like to pay my respect to Excellency Professor, ladies and gentlemen. I am Richard Ray, and it is my honor to share our research on the synthetic and deep learning for bilingual text detection, focused on the low resource Khmer and English scenes. So in here, our content of our presentation, I will start with the interaction and objective, followed by the research motivation and method overview. Next, I will cover the dataset overview, performance metric, and our result and discussion. Then I will highlight the main contribute and share for the future work before ending with the analysis. So you know that in recent years, you have seen major advance in optical character recognition and text localization. However, the success of this system heavily depend on the large annotated dataset that truly represent the target domain. For widely spoken English like the English, the resources exist. But for the low resources languages such as Khmer, the availability of the annotated data is very limited. In Cambodia, the common real world is an example for the shop banner that display both Khmer and English text, different font size, alignment, and often include extra elements like phone number, logo, slogan, etc. The problem is that our model trained mainly on English, so that perform a little bit poorly this this kind of the multilingual environment. To address this, our work proposed the synthetic data generation. It is the cost-effective way to create the realistic annotated automatically Khmer and English dataset. So this allows us to train the model that can handle the complexity of the bilingual text detection in the real scenario. So here's a real photo of a Cambodian shop banner. And this is one of the main motivation behind our research in the limited resources availability in the OCR system, particularly for the unpresented languages like Khmer. Technology still encounter significant difficulty when processing multilingual scripts. Handle different writing systems within the same images introduce the complexity in detection and recognition, often leading to the low accuracy. The second, when we focus specifically on the Khmer, the challenges is even greater. Khmer suffer from the scarcity of annotated datasets, meaning there is not enough high-quality label data to train the robust model. So here is our objective, follow a clear progression. First, we develop a synthetic data generation pipeline for the Khmer and English bilingual text detection in Cambodia shop banners. Second, we address the scarcities of annotated dataset for the low language like Khmer, replacing manual annotation with the automatically synthetic generation. The third, we train YOLO V8 with the synthetic dataset and then test in a real-world image to evaluate how our model perform in the particular scenario. Finally, we aim to improve the OCR system performance in the multilingual, low resources environment. So our result that confirm that synthetic dataset provide a measurable boost in accuracy. So this is a slide for our synthetic data generate pipeline, which produce a realistic annotated bilingual text image for training. We start with the real shop banner image collected in Phnom Penh, Cambodia. The original text removed to create a clear background. Next, we perform a pre-space detection using YOLO model to find the area suitable for placing a new text without overlapping. Then we apply the text rendering with the three configuration: Khmer only, English only, and the bilingual with the English below the Khmer text. Font and style are chosen to match those common scenes on the actual shop banners. Once the text is placed, it automatically generates YOLO format and notation at the both word and line level, ensure the precision of detection tasks. Finally, we apply the visual augmentation such as Gaussian noise, brightness, contrast, change, and blur, etc. So this figure shows that the synthetic data set sample that we take on the front subbanner in Cambodia and use detect a free space and rendering Khmer and English to make to mimic it the realistic effects. So on this slide, I'm showing the example for the synthetic data set that each of photo is on the real banner background, and the color box are automatically generated line or word level annotation with the language tag like English or Khmer. This slide is overview of our synthetic dataset that divide into the three subsets for training, validating, and testing. So the training set is a large portion that contain around 30,000. Next, you see the validation set contain around 6,000 images. Finally, the test set consists of around 6,000 images too. So the next is for the slide that describe about the performance metric of the YOLO V8 model that when we use for test on the real bilingual text image. First, you see the precision is used for measure how accuracy the model positive prediction are. Our model achieved the precision score around 0.80. That's mean 80% of the dataset of meaning that 80% of detection text region are corrected. Next, recall represent the completeness of the positive prediction, especially how much the actual text model were able to detect. Here we achieve 0.74, indicate that 74% of the actual text instant in the images are successfully detected. Finally, the F1 score balance precision and recall into the signal for measurable that we obtain a value of 0.77. It means that it reflects a strong balance between detection accuracy and the completeness. So here for the performance metric on the real banner shop detection, you see the green box show the detection of the text on the real banner shop. So here is the precision and recall performance of the YOLO V8 model that we are training during training over 100 epochs. So here for the Khmer text detection, our model shows a strong performance and effective for the synthetic dataset. That means that our generated synthetic dataset successfully capture the characteristic of the real world Khmer text. So in contrast, the English text detection faces more challenges. Maybe sometimes because of the first challenge is the small size of the English in the Cambodian banner shop, and some for or another challenges such as the font variation. To wrap up, we tackled a short take of a label data for the Khmer-English text localization for building a synthetic data generation framework that create the realistic training sample without costly manual annotation. You see the first is a data creation that we generate a bilingual dataset for the detection for first detecting the pre-space on the real short banner background, and then rendering the Khmer and the English text realistically and export the YOLO V8 annotation. It's giving us a large, diverse data set for training in Cambodia Senate. The second is the model performance that we train on the dataset using the YOLO. It performs effectively on the real images, especially for the complex Khmer script and cluster scenes. The last is for the real world application. So the result that show that the approach is practically for the low resources multilinguality, where the challenges and the labeling real data is difficulty. This pipeline show that annotation cost while realism make deploy file for retainable. So our work delivers three major contribute the bridge innovation with the measurable impact. The first, we develop a data auto generation pipeline dataset. So this pipeline allows us to generate the large volume of the high quality synthetic data effectively, which is crucial when the real data is limited or expensive to collect. The second, we provide the fundamental work for the multilingual OCR. This is the fundamental research designed to support the further optical character recognition tasks, especially for the languages that are less represented in the existing dataset. The third, that we bring the empirical evidence of efficiency through the rigorous. We have demonstrated the clear proof of our model effectiveness in processing Khmer and English text. For looking at ahead, we will extend this work along four tracks. So the first, increasing data diversity, that we will add more background scene and font style. Second, integrate real world images, that we will merge the subset of the manual verified real banner into the training for or finding or fine-tuning to robust and narrow the synthetic to real gap. The third, evaluation the synthetic dataset with the multi-text localization model. And fourth, compare the model performance, that we will benchmark the accuracy, F1 score, speed, and the computation cost to identify the cost-effective approach for deploy for the Cambodian sub-banner setting. Before I close, I would like to acknowledge the people who support make this work possible. First, Excellency Professor Hao Pei, Rector of National University of Management, for his continuous support and generous sponsor my study PhD. Second is Professor Chai Pang, Dean of Faculty of Information Technology, for his invaluable guidance and consistent encouragement through my academic journey. The last but not least, I want to thank for reviewer for their thoughtful feedback, which have strengthened this research. Come to the end of my presentation, I want to extend my heartfelt thanks to everyone for. Thank you.